Yeah, hi folks. When I introduce myself in English, I usually say that my name is Anastasiia, and they pronounce it like nice to see you. And it's really nice to see you all in here. Today we are going to talk about test analysis, and in spite of its name, this topic will cover far more than just quality assurance and than just quality engineering. Let's just sufficiently look at the structure of this talk. So just to know what you can wait for. Firstly, I'll introduce myself and give some theoretical overview on the test analysis. What is it, why we need it, and which approaches can we use to incorporate this test analysis into our life. Then we'll play a little game. I will just provide with a couple of interesting cases, and using the mentioned techniques, we will together figure out what's wrong. And then we'll finish with some outcomes of how to incorporate the test analysis stage into your product's lifecycle. This might be interesting not only for the test engineers, as I have said, but also for the product managers, for the developers, and for basically everybody who cares about the quality of the software that your team provides. Yeah, of course, there will be a place for questions and discussions in the end. Here I wanted to present myself, but instead of it, I've just decided to tell you a little joke. Like about an hour ago, in the next room, there was a beginning of the joke. Like the test engineer goes into the bar, then the test engineer falls into the bar. Test engineer rides a horse into the bar, orders 1 beer, minus 1 beer, infinity beers, and then the real users go into bar and ask where the toilet is, and the bar just explodes, everything is on fire, and everybody screams. So basically, this is why we need test analysis, to prevent those situations and not to run into the bar on our riding horse, but to ask the proper questions and prevent everything from burning up and exploding. Yes, let's dive right into it. Which problems each software development team face? First of all, it's building test bases, building some valid checks, especially in situations with minimum requirements. Could please anyone here raise a hand if there was at least once in your life that you just joined a new team, everything was documented, the requirements were full, complete, and everything was comprehensive? Yes, just as I thought. So that's a real problem that almost everybody of us faces someday. Then it is also important to find bugs, not just find bugs, but find relevant bugs and important bugs. Some bugs are better than others. Some bugs cost more expensive. Maybe also some of you can raise your hand if there was a situation when you have reported or you were reported a bug, which is quite valid, but absolutely non-critical, that's not a priority, and you think just, why the hell we are focusing on it when there is some much more important functionality to be tested? Okay, yes, we all did, especially the junior test engineers, sometimes guilty with this. Then we need to reduce our testing costs and efforts. It's really important, not only in terms of releasing the software faster, it's only important when we are talking about just costs that are important to the company. Mostly it's a headache of some team leads, but why not? Sometimes any of us can face it. And for sure, it is important to share the product knowledge among the team. And it can be actually a big problem. Also asking you to raise a hand if there was a situation when you came into a new team and there was, that one sophisticated, old, experienced engineer who knows everything, and you always come to this person when something is not clear. And you definitely understand that if bug factor is happening to this very person, then we're doomed. Yeah, many of us. That's nice. Nice to see that we are sharing the same problems. And, of course, we want the same solutions. To start with, we want our team to collaborate. We want the knowledge to be shared. We want our team members to speak to each other. That's a pity when a designer makes something that is hard to implement by the development team, or when the development team implements software that can't be properly tested, yada, yada, yada. So yes, we definitely want to speak it up before it happens. Optimization of testing costs is something we have already mentioned. Sure, we want not only to develop our software, but to be sure that the important requirements are not missed. Therefore, we need to reveal them. And it is better if you reveal them before the development starts, because you know the Bohm's law, we are going to address it a little bit later. For sure, we want not only finding relevant bugs by ourselves, but also making our tests finding them. And we want to gain the product's expertise among all of the team, so that not only one old, sophisticated, experienced developer is the source of truth, but like the whole team can be responsible and can answer specific questions regarding the software and everything that we can be interested in. And what if I say you that test analysis is something that can resolve all those problems and bring us all those solutions, especially when it's performed in early stages? Could anyone frankly tell me if you try to incorporate test analysis and to like distinguish it from the test design? Okay, then you are the target audience for my talk. Nice to see it is here. Yeah, I'm really happy. In this phase, you can tell me that test analysis, early requirement review, yada, 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 can work for shiny, bright, fancy agile methodologies, but we have this crappy waterfall and nothing we can do. We have a legacy product that just can be turned another way, or it is just functioning like this and we're not able to change anything. Then I'll tell you that actually it will work, even with the waterfall methodologies. Look, test analysis is not about testing on the early stages, but more about analyzing. Both in the agile phase, we have this early plan stage where we figure out what will be done in this iteration. As well in the waterfall flow, we have those requirement stage, when we are collecting some data and information and just documenting it so that we can understand what's going to be developed. Does this remind you of something? For me, mostly, yeah, this is the Bohm's law that can be addressed talking about the early catching of some bugs and issues and defects. We all know this law. I believe that many of us were taught about the cost of the defect found on the analysis and early development stages. It is far cheaper than the defect found in the production or testing time. And it's pretty obvious, but then, if it is obvious, why do we fail to reveal the defects and issues in the early stages? Why we even have those defects on this stage? Is it so hard? I believe that sometimes we just don't know how to properly approach the analytic stage of our software. And we are a bit scared because not every team has test engineers and test analysts or just analysts that can address this. Well, then let's get a quick look on how we can do it ourselves, as developers, as managers, as any person in the team who is interested in the software quality. Yeah, the most important part here is to remember that we are talking about test analysis, but we are focusing on the word analysis, not on the word test. Yeah, let's get into the next part and just have some synchronization of what test analysis is. According to several sources, test analysis is a kind of process of checking the test basis, testing artifacts in order to design some testing flows and checks. I find this very definition not really correct because, sometimes we just don't have any testing artifacts in the very beginning. Just to explain, testing artifacts is any documentation that can be used for testing or that can be used as a basis, as a source of truth when talking about our software. It is definitely the requirements, the specification, some early testing strategies and plans, and so forth. Then, other sources address test analysis as a process of deriving test information, deriving it from standards, from specifications, other products, from typical behavior that users expect to perform in this very type of application or web service. It can be anything. It's just understanding of what we are doing and why. I believe it's also not fully reflecting the depth of test analysis, but it's definitely better than the previous one. And the last one that was provided by like the god of modern testing, Michael Bolton, is that test analysis is challenging the product, challenging it in social context, remembering which users are gonna use our product, remembering which goal do we have, and mainly just having some interest into what we are working with, exploring it like a new territory. Basically, to sum up, I would say that by test analysis, I personally mean exploration and challenging the software. That's all good. We know that test analysis is necessary. We know that we can challenge and explore our software, but how exactly should we do it? There, I have divided several parts that can be used for test analysis by any team member. It doesn't matter if you are a developer or tester, you can try to implement this just because it's kind of general knowledge that you will gain and you will find important. First of all, let's focus on the requirements analysis. It's something that we can logically assume. Yes, we have some requirements, some expectations, so we need to analyze them. Probably some of you have seen those characteristics of good requirements or good specifications. Just raise your hand who have seen those characteristics before. Yes? Okay, yeah, because it is taken from the ISTQB standards. It's nothing fancy new. Let's forget about it for this very moment. It's the characteristics of testing the specification, but we are talking about test analysis. In this case, we need to look a bit deeper and at the same time, a bit more superficial on what we are going to work with. We need to arrange several points of views, clarify the project's goals and objectives. We need to think for whom we are doing this very software, who will be our users, what will they find important, and what will definitely catch their attention. Then, based on the derived information, we need to identify the crucial functionalities and features that we will focus next, like when developing, testing, and so on. As an example, let's imagine that we are developing a big all-in-one software for development teams. It includes Git hosting, code review functionality, some issues and boards, chats, documents, and more. We can assume that as our target audience are developers, we need to make Git hosting and code reviews functionality flawless. At the same time, there are many competitors like Google Documents or Slack or Microsoft Teams that provide us with the documents and chat functionality. Therefore, it seems like a little bit less prioritized task. So by decomposing our application and its goals one by one, we can understand what is our main focus, as for development, as for testing part. This way, we can assume how many of our efforts should be put into this very part of functionality. For sure, we also need to assess potential risks and address it. When talking about the Git hosting functionality, we can always assume that at some point there will be a great load. This way, we need to think about the load testing from the very beginning and probably about building some kind of good infrastructure for future load testing, even though we might not have the performance testing team now. Sure, there's also some more tasks like developing the high-level strategy and beginning drafting some checks on the early stages, but this can for sure be delegated to the testing team. Okay, we have looked through the requirement analysis. Now let's think about some heuristics. Testing heuristics and mnemonics means some abbreviations or some general approaches that were proven to be good and that were invented and used by many, many people. For example, when testing the email field, we know that it is important to test like the email that was already registered in the system. We need to test the email with some non-typical characters like brackets or plus symbol that should be accepted by the field and so on. We know it not because we have missed those bugs, we know it just because like this is the standards for testing the email field input. Does any of these heuristics seem familiar to you? Okay, I see some of you are nodding your hands, so probably I'm not gonna talk much about each of it. Let's just see a couple of them as an example. SFDPOT, or as called San Francisco Depot, was invented by already mentioned Michael Bolton. It is just a general approach to testing any functionality which can be incorporated, like let's say when you're joining a new team and need to understand the all scope of what should be done. We're talking about the structure of our software, which instances does it have, how many gateways, how many microservices does it have on the back end, and so on. About the functional part, what does this software do? About the data part, how the data is stored, what do we do with the gain data? The platform solutions, like which platforms should be the software developed for. Operations mean anything that happens inside under the hood of the mentioned software. And time means anything that you can imagine connected with time. It means time zones, dates, different date formats, the time of keeping, let's say, the user session, and so on. And also there is one good mnemonics that I really like. It's called failure, and it addresses actually failures. It addresses the failure messages of different errors in the system. Basically, probably some of you have seen the different error messages, and maybe you have wondered why some of the error messages cause just a slight smile and a desire to try it a bit later, and some of them are just making us want to throw our laptop in the wall and smash it and never visit this site again. I mean it. Some error messages are far more usable than the others. We need to understand that the user message should be functional. It should tell user what has happened, but not diving too deep into it. We also need to impact user in some way. We need to give them some opportunities what to do next, like to go to the home page or to try again later. It is also important to log the very error in our backend and provide some UI elements for the recovery. Also remember which emotions does this very message cause to our users. It's more the question of some UX researches, but still we need to think about it. As you can see, if you occasionally have the task to test errors in any system, it will be quite challenging just to come up with what should be tested out of nowhere. But using those mnemonics and heuristics, we can just address those aspects of quality that were already proven to be efficient by other people. Yeah, we've dealt with half of the approaches of test analysis, and let's skip to one of my favorite ones. It's bisecting, one of the types of software decomposition. By this moment, you probably know that it is crucial to know how your system works, which services and which components does it have under the hood. Therefore, we can debug and find the error source in the most efficient and time-saving way. First of all, we need to define the possible problem scope. Like when we are facing some error, we need to understand either it happens on the front end or on the back end. If it happens, let's say, on the back end, we need to understand either it is related to the server logic or the database functionality, and so on and so forth. Then, when we have defined the problem scope, we need to understand the division criteria. It may be the logical type of division, like front and back end. It can be the division by the recent commits. Like we see that 6 commits ago, there were no bugs, and now this very problem occurs. Then we divide those commits by 3, and if the first 3 commits are functioning well, then definitely the problem is into the last 3. Then we are dividing it into some possible ways, like 2, 1, and proceeding until we divide it and find the very problem. It seems a bit obvious, but as far as I have noticed, especially from my own behavior when I am facing the bug, I tend to assume the easiest way from which it can be caused and forget about the fact that it can have several aspects. The good part of bisecting, of the division and decomposition, is that before you decompose, you need to think about all the components that can be involved into this very harmful behavior. This way, even if you fail to decompose properly, you just refresh your knowledge about the product and you help other people who have more expertise to think, like to take a fresh look onto what was wrong. And the last but not least, and one of my favorite parts, is for sure the product expertise. Maybe some of you can remember, if you have worked in a company for a year or more, at some point you understand that there are several nuances that you have not only witnessed being born, but maybe you have also contributed to them, like some software behavior, some frameworks that you use. Just raise a hand if these situations happened to you at least once. Talk to me. Yeah, nice. So this means that you have gained the proper product expertise to continue working with the product and to continue sharing the knowledge. But of course, we need to spread this expertise among the team. First of all, it is crucial to understand product's purpose and goals. It appears to me that I have already mentioned this, but trust me, it's a really important point. By any means, no matter how deep we are understanding the technical parts of the product, if we don't know who are our users, what they find important, and what is crucial for them, it will be just nothing. Then it's definitely participating in design and planning meetings. It is important not only for gathering the knowledge before it was announced for the team or planned into the sprint, but also for some kind of understanding the logic of our colleagues and for contributing into some functionality that can be crucial from your point of view. I can also highlight that on those stages, we can contribute into making our software more testable, like agree on adding the data test attributes on the early stages. This way, writing tests in future will be much easier. We can just rely on the mockups and then add the necessary locators, but it's another story. For sure, we need to read the documentation. It's something that we can call the basis. But sometimes there is not so much documentation, and then we can read the code. It's not obligatory, for sure. There are many people in the team who can't read code just because they don't know its logic. But if you can, don't ignore this possibility. It's really important just as from the point of a fresh view, as well as from the point of view gathering some more technical understanding of how your product works. It is also a kind of good practice to make some schemes of how components are interacting with each others. I have noticed it myself, there is a common knowledge that is shared among the team, but when you start drawing those schemes, which services do we have, which information do they provide to each other. We can understand that there are some nuances and some small details that were not considered before. So this way, we are not only making sure that the team has synchronized knowledge about the product functionality, we also are contributing into making our onboarding easy for the new team members in future. It is good to think about this in advance. For sure, it is a good practice to explore some competitive products. I believe many of us have done it. And yes, document everything. It's something that I really like to spread into each team where I participate. I love creating documentation. It doesn't mean that we have to create long, boring specifications like small meeting notes or small bullet lists are pretty enough. We just need to understand that none of the important knowledge was missed. Also, it's a good point to contribute into the onboarding in future. Sharing knowledge among the team is something that can be done in several ways. It can be some type of knowledge base in the Confluence. It can be done via shared meetups or strategy sessions where the whole team discusses current state, functionality, and the way the product works. I believe that's something that the team can decide what works for them. However, I believe it should always be fun, because if we are not doing it for fun, then why? Okay, we are done with the theoretical overview. Now let's play a little bit of games. The first case is this example. We have the web page and some code on it. Let's say it's a JavaScript code snippet. Also, we have this very button that says click me. By clicking this button, we are redirected to the desktop application, let's say to the IDE, that opens this very code in it. The code is transferred via some plugin. So yes, basically the page is connected to the IDE via that plugin. We need to test that functionality. Considering the test analysis approaches that we have reviewed, could you please assume what would you think about? What questions will you state, and which important sides of this integration do you see?
The communication protocol.
Yes, the communication protocol. Good point. I would also say that it is not only about the protocol itself, like is it HTTP or WebSocket or something like this, but how it is really communicated. Are there any components under the hood of those link? Okay, maybe something else? Yeah, that's a good point to start with. Let's assume that's the only requirements that we have. The goal of the feature is to open the code snippet from the web page in the IDE, pointing to this very code point. But it's also a kind of good question. Let's say we are cloning this very repository or part of code into our IDE, into some new or existing project, depending on it. Yes, that's also a good question. What do we want the user to do with that? We want the user to navigate from the web to the IDE, let's say when they are reviewing some part of code in the web and they understand that they don't know what this precise method means. They want to open the code in the IDE and dive deeper and deeper into the method declaration just to understand how it works. Okay, I guess.
Yeah, but it's the first version is repository, right? The first like system is repository.
Yeah, I'm repeating it just because it might be not too loud from the seat. Yeah, the first page is the web editor, and the desktop application is a kind of IDE. Okay, I guess there were some important points mentioned already by you. Thank you guys for contributing. First of all, when we were thinking about this very integration, we understood that there is a WebSocket connection that might be occasionally closed. This way, we have found an important bug. Also, we have understood that this web editor can navigate us through files itself. So probably there is no point for the user to especially click this button to dive into the desktop application and web plugin. And also, by asking what our target audience, what do they want to do, we have understood that the users that would open the desktop IDE are usually not using the web desktop editor. This way, we can state some important questions and find the issues that we can address even before it was developed. They are just the mock-ups. So, yeah, good work. Okay, that was kind of feature review. Now let's think about the debugging process. Like, yeah, there is a mystery that we need to solve, just as some detectives. Let's assume our users have the paid subscription to some urban dictionary. They can find the abbreviations in there and see some definitions. The important point is the database containing the definitions can be updated. This way, we can assume that there can be new definitions that are appearing here from time to time, and the user can click the button Update, then see this very loader, and see the new definitions in case there are some new ones, and see an error if the update failed to finish. One day, the user clicks those those update button, and after some time of loading and updating, they see this rate limit error, like too many requests. Your limits are reached, you cannot update it anymore. The user is definitely confused because they just didn't get any new information, they didn't get any error, only this rate limit error message. It is especially confusing considering that the user just clicked update one time. They didn't click it like 100 times. We, as quality engineers or as a development team, need to understand what happened. A little bit of hint here. We can dive into the decomposition to find the source of this error. Any ideas? Yeah, that's a good one. That's not a debugging idea, but a good one just to change the message for the user. They just can't get what happened.
No, just the color of the message.
Yeah.
To the white color.
Yeah, then they just don't get what's wrong. If you can see it, it doesn't exist. Okay, let me start. First of all, we can try to decompose where the error happened, on the front end or on the back end. Your ideas? Back end, right. Okay, on the back end, we have some services, like the service that provides us with some updates, the service that have some message queue for those updates, and the service that is responsible for the rate limiting. Choosing between those three services, which one is most likely to be corrupted? Okay, that's a valid. Limiting is a valid assumption. But looking into it, we can understand that their limits are counted just right. There are no problems with it. We have two more services left. It's the updating service, and it's the service that contains, let's say, our logic, our other logic. Okay, the update service. It requests some updates, and yes, their requests are just right. So we get the message from the message queue, we get the task, and we're performing it. The update happens. Nothing wrong with it. Then we have the message queue provider, and we have the general service with some errors. keep decomposing. Yeah, message queue. Okay, let's dive into the message queue. We see that the messages are just right. None of the messages are corrupted. The structure is okay. The IDs, the tasks, names, and so on is also good. So we have only one service left, the main logic service. Diving into it, we can see that there is no proper error message. So when error happens when trying to get the data from the database, we don't put the error message in the message queue in this queue provider. We are just putting there a new task. Therefore, the user gets this new task, and this updates keeping happening until the limit is reached. When the error message that should be put into the message queue is fixed, everything works as intended. So congratulations, we have just debugged a pretty tricky problem. Yay! Okay, that was some practice. I hope that by this I have shown you that the test analysis process is not something that can be done only by testers. We all can just implement and apply those techniques to think from the other point of view, to look to our functionality and just to assume what the problem is or might be. Now, let's think about how to incorporate the test analysis stage into a product lifecycle. Let's imagine you're a startup that doesn't have any strictly defined processes, and you want to make test analysis something common for your team. What should be done? First of all, we need to think about what already has been done. We can assume that in your team there is a bunch of analysts that can thoroughly review the requirements and understand what is missing. Also, we can see that there are some experienced developers that have great product knowledge and are sharing it among the team. Then we need to understand what should be improved first. In case if we have a good requirement analysis process, we might not have like a big bunch of people who can analyze those requirements. Or maybe none of the people are understanding how it really works. So the knowledge should be spread. In the second case, it may be a really good source of truth among the group of developers, but let's say that the team doesn't understand what are we doing this for and who are our target audience. Then there are several issues that we can see and address immediately. After this has happened, we need to think what else is there. So we are just going step by step and then reviewing and analyzing what has already been done. Then the cycle repeats and repeats. Does it remind you of anything? Agile methodologies, and especially the German wheel, or German cycle, as we call it. It's plan, do, check, and act. In this very case, we need to figure out which parts of test analysis are crucial for our team, and using those iterational approach, incorporate it step by step. You might be a bit disappointed. Like, are you telling me there is no silver bullet? There is like no process that I can just take, use, and everything is okay? Yes, you've got it. There is no silver bullet, as we can say for the many aspects of software development and testing. But you know what? Now you know some approaches that can be used like the next day after this talk. So please feel free to address them. Feel free to remember how you can influence the quality of a product, even not being a quality engineer. And you're always welcome to state more questions. If you don't know what to start with, you can always start with this simple mnemonic that I have came up with during my almost 7 years of working as a quality engineer. It's SIP and CUT. SIP states for the scope, impact, and priorities. We need to understand what our software consists of, how parts of this software impact each other, and which priorities do we currently have, like which parts are the most crucial. Then we need to think about costs. It's not only about costs in the team lead understanding, like the costs of our development and so on. It's mostly about like the types of users, the types of subscriptions, the functionalities that can be logged under some paid subscription, and so on. Also, we need to think about users. Who are our users? What are we doing it for? And how they will perceive this very functionality. And also about timing. It's about the development time. It's about the time restrictions, as have already mentioned in the San Francisco Depot mnemonic, like the time zones, the time limits, the time of living of user token, and so on and so forth. So please feel free to use this very heuristic just to start analyzing your product from the new point of view. And that's it. Thank you so much for the attention. I am happy to answer any of the questions.
So, who want to ask a question? Okay, I'm going to you.
Thanks a lot for the talk. So you mentioned documentation and knowledge share. And quite often when we think about documentation, we only ask ourselves how to store it. But actually, the more important question is how to make it useful for people who will search for something. So what's your best practice?
Okay, definitely my best practice, thank you for the question, first of all. Definitely my best practice is visualization. As I have mentioned, like creating some mind maps, some schemes of the functionality and its components is something really useful. First of all, I would say that just seeing how those components interact is something that makes the abstract knowledge more exact, more concrete, which is easier to perceive by any team member. And also it allows you just to manage its connections and to manage the whole pictures in pretty easy way. I believe that fixing something on a scheme is easier than fixing it in a number of articles in knowledge base. So I believe that depends on the person who you want to share knowledge with, but my best practice is definitely mind mapping, impact mapping, making different types of diagrams that the whole team can see and just estimate.
Okay, so we have time for one short question. So, or we can end earlier.
Okay.
So, thank you very much for your...
Thank you.